Welcome back, students, to the unit 2. In this unit, we will discuss about sampling error and the p-value. Sampling error. In any research, for example, we have said population cannot be studied at all and we have to take in only a sample. The nature of the sample we take consists of certain degree of errors. So there is always a difference between a sample statistics and a population parameter. For example, if you want to study a particular group of individuals in a society, society has varied number of characteristics in terms of age, in terms of their religion, in terms of various other backgrounds that are there. And can we take all these into consideration when we want to study a phenomenon? So that is where we take only a sample. And when we select a sample, three important components become very much essential. That is where we talk in terms of representativeness, sample size, and randomization. These three play a significant role, and the value of your research tend to depend upon to what extent your sample has all these three. And these three itself is a main component for the errors also. In a study or in an empirical study, the subjectivity of a researcher should not come into the picture. The sample that you select should be more objective. That means the person or the researcher should not select a sample that he or she knows that that particular respondent is known to me. Now, randomization refers to a simple procedure where every member of the population has the probability of either being selected or rejected. Now, when an individual has the criteria of either being selected or rejected, now that ensures the objectivity of the research is concerned. Now, let us discuss about the p-value. What is p-value and the importance of p-value? Comparison of p-value with the t-value we will try to discuss. Traditionally, the estimation of error due to the chance or measurement was computed by calculating standard error of mean difference. Student t-test is a popular statistical test used to verify the hypothesis. The component of t-value, the ratio of the difference between the two means to the standard error of mean difference, a value of 1.96 and 2.58 for an n greater than 30 are set as a limit to accept the difference observed between the two means to be statistically significant at 95% and 99% respectively. In other words, 0.05 or 0.01 respectively. Hence, if a researcher gets a t ratio that is greater than 1.96 but less than 2.58, he will accept the alternate hypothesis to be true at 95% level, and if the obtained t ratio is greater than 2.58, the hypothesis will be accepted as true at 99% level. On the other hand, if the obtained t ratio is less than 1.96 for the n greater than 30, the alternate hypothesis is rejected and one needs to conclude that the result obtained has a greater degree of chance factor affecting the result. Why 1.96 is because 1.96 standard deviation will cover 95% of the cases in a normal distribution. The p-value or the calculated probability is the probability of finding the observed or more extreme results when the null hypothesis of a study question is true. The definition of extreme depends on how the hypothesis is being tested. While the t-value is a statistic that is applicable to the sample, p-value tells us about the statistical significance of the difference. While the significance level is used to refer to a pre-chosen probability, p-value is used to indicate a probability that is calculated after a given study. The difference between the t and the p is that the larger the t-value, the null hypothesis is rejected. And the smaller the p-value, the null hypothesis is rejected. It is said that while the old school used the t-value, the new school advocates the p-value. Every t-value has a p-value also. Let us understand these terms and concepts with an example. Suppose a researcher wants to compare the differences in the degree of acceptance of ideas that is propagated through television between urban and rural population. He would frame a hypothesis that rural population has a high degree of acceptance than the urban. The degree of acceptance of the ideas are measured using an appropriate scale. In order to verify the hypothesis, the researcher collects the data separately from the urban and the rural sample consisting of 50 members each. After obtaining the scores, the researcher runs descriptive statistics for the two samples and finds that the mean scores for the rural and the urban sample as 55 and 58 respectively, with a standard deviation score of 1 and 5.50 respectively for the rural and urban sample. Comparison of mean scores of the two sample reveal that the urban sample has a higher mean score than the rural sample, which mean the degree of acceptance of ideas propagated through media is more among the urban than the rural population. Comparison of standard deviation scores of the sample reveal that the degree of standard deviation is greater in the urban sample than the rural. The simple understanding of the above score would mean that the result of the study is against the hypothesis, as urban sample has a high mean score on acceptability of ideas. However, the comparison of standard deviation of the two samples reveal that the degree of individual differences from the mean is also high among the urban sample. Based on these, can we draw the conclusion that the hypothesis is to be rejected and state that the urban sample have a higher degree of acceptance of ideas than the rural sample? In statistical terms, the variance in the mean scores between the urban and the rural sample to the tune of 3 points is composed of variance due to the actual or the real difference between the samples, as well as variance to the chance factors that was not controlled by the researcher. Hence, it is necessary to examine whether the difference between the two samples is statistically significant by extracting the error variance from the total variance. Assuming 5% level of significance, what should be the amount of difference between the two means to be statistically significant? Let us calculate the t-value and test whether, based on the observed difference of 3 on the mean scores, the hypothesis could be accepted or not. T equals mean difference using the obtained t-value and taking into account the degree of freedom the p-value could be obtained referring the table. Well, students, in Unit 2, we have discussed about the sampling error and the p-value, the differences between the t and the p-value, and the importance of p-value that is being given in the current research trends. Now, let us summarize the module 16. A normal distribution is also known as a bell curve that represents a distribution that occurs naturally. It is based on the theory of probability. All statistical tests assume the normal distribution of the variable. Deviation from the normal distribution is measured in terms of kurtosis and skewness. And in an empirical research, the researcher manipulates the independent variable and tests whether the effect of manipulation is significant or not. Variance observed due to manipulation could be either due to the effect of variable itself or due to the chance or the error factors. Significance level estimates the degree of chance or the error variance. Normally, 5% of variance due to the chance is accepted. P-value tells us about the statistical significance of the difference. Thank you.